So for skill 2, we had to find the radius of a circle, and we were given the central angle of the circle, and we were also given the ratio of the sector area over the arc length. So the first thing I did was define what the ratio was, and that ratio was 6. And then I also defined my variables. So the arc length, I chose S to represent it, and for sector area, I chose A, and radius is R. So first what I did is I created an expression for the area sector. So I used proportions to create this expression. So it would be part of the circle over the entire circle is equal to the central angle, or a part of an angle, over the entire angle. And the entire angle would be 360 degrees since this is a circle. Now instead of 360 degrees, I use 2 pi because it's easier to cancel out variables that way if you have a pi in a different part of this expression. So the area sector is represented by A, and that's over the total area, so that's the formula pi r squared, and that's equal to the 36 degrees, which is the central angle, over 2 pi, which is 360 degrees. Now I solved for A, and I got A equals 18r squared. So this is the expression for the area sector in terms of r. Next, I did a similar approach with the arc length, and again, the arc length for here, I did part of the circumference of a circle over the entire circumference is equal to a part angle over the entire angle. To be arc length over circumference, which is S over 2 pi r, is equal to 36 degrees over 2 pi, and 2 pi again represents the 360 degrees. Now when you solve for S, you get 36r. So now you have an expression for the area sector and the arc length. Now you can use these two expressions to solve for the radius because they're both in terms of r. So here you have, from the original given problem, you have the area over the arc length equals 6. So that was your ratio. So now you can substitute the expressions you found, and so you get 18r squared over 36r equals 6. And now, since you only have one variable, which is r, which is what you're trying to solve for, you can solve for it by isolating r, and you get r to be 12. So therefore, the radius of the circle that has a sector area ratio to arc length equals 6, it has to be 12 units.